Hey folks, thanks for watching the video. I just wanted to show you, yesterday we did some solving by substitution, right? So if we look at the problems that the textbook claim are good substitution problems, none of these equations here are solved for a particular variable. So I think what they're doing is they're giving you a choice. Do you want to solve the top one for a particular variable or the bottom one? Well, you could solve the top one for y. That'd be pretty easy to do. Or you could solve the second one for x. That might be easier to do. It'd be like one step if we just subtract 3y from both sides, right? So now we would have x equals negative 3y minus 6. See, this is what you're going to substitute in for the x back here in the top equation, right? So I would have 2, so this is problem number 1, 2 times negative 3y minus 6, and then minus y, there's the minus y part, equals 9, and we're going to solve for y, right? But today's main feature is solved by the elimination method. So yesterday we did the substitution method on Desmo's classroom, and I think they were easier. Let me just say one more thing about this before we move on. One of the two equations was already solved for x or solved for y, right? So you were just doing the basic substitution method. Down here, you can see, well, none of these are solved for a particular variable, and they're maybe set up better for the elimination technique. Let's take 10, for example, okay? So why is 10 perfectly set up for the elimination technique? Well, look at the y variables right here. See how that's a positive 2y and this one's a negative 2y? Well, they're the same coefficients, but just opposite in sign. So when we add the two equations together, the y's are going to get eliminated. All right, all I got to do is add the two equations together and the y's are going to go to 0 y's. So when I add the x's, you got to be careful. 5 plus a negative 6 is a negative 1x, so I get negative, I'm going to put a 1 there. Usually we don't do that, right? And then you got to add the 12 and the negative 14. We're adding these two together, so 12, well, plus a negative 14 would be a negative 2. Okay, so then we would divide by negative 1 on both sides, and we get x is equal to positive 2. Okay, now I guess every method you do at some point is a substitution problem, because now we got to substitute back in to one of the equations a 2 for the x variable. Okay, so I'm going to plug a 2 right in that x spot right there, and I end up with 5 times 2 plus 2y equals 12. Well, let's see, what do I get? 10 plus 2y equals 12. I subtract 10 from both sides, and I get 2y equals 2. And then I divide by 2 on both sides, and I get y equals 1. Okay, so I always want you to write the solution as an ordered pair, because that kind of emphasizes that it's the point where the two lines intersect, right? So my final solution is going to be written again as an ordered pair. Now, what do you do about ones where the variables, like right now, that's a negative 2 and that's a positive 3. If we added these two together, you get a positive 1y. If you add these two together, you get an 8x. So they're not going to 0 like this one did. When we added this second equation to the first equation, the y's eliminated. They went to 0. So this one right here, number 9, we're going to try this one together right now. We're going to have to set it up so that one of the equations we're going to multiply by a number, and the second equation we might multiply by a different number, so that the coefficients end up being the same, like this, like 2 and negative 2. Well, opposite in sign, though. We'd love them to be opposite in sign. So what if I multiply the top equation by 3? Okay, so I'm going to multiply everything up here by 3. And now that becomes 9x. Well, why is that 9x? Because 3 times that 3 over there, right? So I got 9x, then minus 6y, and then we would have 12. Well, no, y minus 6y? Well, I'm taking 3 times that negative 2 right there, right? And 3 times the 4 gives me 12. All right, so let's try a different color here. Let's go green. And I'm going to multiply the second equation by 2. So let's multiply everything down here by 2. And that becomes 10x. And then plus 6y. Here's the key. See, that's why I multiplied this one right here by 2, so that I'd have the same numbers but opposite in sign. And then on the right side, I would have 2 times negative 25, which is negative 50. Okay. Now we're going to add the two equations together. And you can see that, oh, look at this. The y's go to 0. The x's become 19x. Now, a lot of times textbook problems, you can divide, both sides, and 19 goes into whatever number's over here evenly. Well, we're going to see if that happens right now. So when I take negative 50 plus 12, I get negative 38. Oh, look at that. That's perfect. And then when we divide both sides by 19, yep, that definitely gives me x equals negative 2, a nice solid whole number right here, an integer, I should say. Okay, now I'm going to take my negative 2 and I can plug it into this equation. I can plug it into that equation. I can plug it all the way at the top. I can plug it into any one of these. Oh, wait, not into number 12. Sorry, we're doing number 9. I can plug it all the way back up here. And so let's do that. Let's go and plug it into the very top equation. And we're going to plug it in right for that x right there. So I get 3 times 2 minus 2y equals 4, right? So I get 6 minus 2y equals 4. I subtract 6 from both sides, right? And I end up with negative 2y equals negative 2. Oh, that's nice. And when I divide by negative 2, I get y equals 1. So my y is 1, my x is negative 2, so I write my final answer as an ordered pair, negative 2, comma 1. That's the elimination technique. Sometimes you got to multiply each equation by a different number to make the coefficients the same but opposite in sign. That way, when you add the two equations, that variable, that y variable, drops out. It could be the x variable. We could have gone for the x variable dropping out or eliminating by multiplying the top equation by 5 and the bottom equation by negative 3. That would have made this one 15x and negative 15x down here. It's up to you. Got to use a little creativity. There's not just one way to do these problems. Thanks for watching the video. Appreciate it.
Good morning.